Hello and welcome to the Humans of Forensic podcast. My name is Ness and I'm a fourth year forensic biology specialist and one of the IVNVI year representatives.
Hi everyone, my name is Michaela. I'm the year representative chair for IVNVI this year, and I'm in my third year of the forensic biology specialist.
Hi everyone, I'm Tasneem and I'm currently in my fourth year of my forensic biology specialist, and I'm currently a fourth year rep for IVNVI. And today we're going to be interviewing Dr. Nicole Novroski, a forensic geneticist and assistant professor here at UTM.
So Dr. Novroski, if you want to give a brief introduction, feel free to do so.
Okay, well, hi, I'm Dr. Nicole Novroski. As mentioned, I am an assistant professor in the forensic science program at UTM and a faculty member in the anthropology program for the University of Toronto system. I am a forensic geneticist by trade, so my research focuses on forensic genetics technologies and utilizing different research approaches to answer various questions in forensic genetics. I am a UTM alum. I've spent a lot of time in a lot of places, which we'll dive into today, and I'm happy to be here. So thank you for having me.
Yeah, it's good to have you. So we're going to start off just kind of general overview. So in your opinion, or your own words, what is forensic biology, or more specifically, forensic genetics?
Sure. So when you think about forensic science, we often think about applying scientific methods to assisting various crimes or utilizing scientific techniques to assist the police or in the criminal justice system. So when I speak about forensic biology, we're really focusing in on biological materials or evidence that has biological substrates contained within it. When we think about forensic genetics, we're really diving into, at the molecular level, utilizing genetic technologies and methodologies to exploit the biological material that's present on those evidentiary items. So thinking about the potential DNA or the potential biological materials that are there, maybe the cellular properties, some cellular information, microRNAs, messenger RNAs, all kinds of things that we can utilize to then potentially identify an individual to an item, to a location, identify individuals to one another, make paternity and or kinship determinations, all just utilizing the biological information that was left behind at the potential crime scene or at the mass disaster event, whatever it may be.
So taking your definition of forensic biology, what is your role as a forensic biologist in, given a typical case?
So that's an interesting question because it will really depend on where you work. Where I sit now as a researcher and as a forensic expert that may be brought into a case on the defense side or on the review side, my role would be to look at the evidence that was collected, look at how a laboratory has processed that evidence, and review that processing chain of custody and all of the findings and results that were generated to ensure that the proper conclusions were reached. But in reality, a forensic biologist in a typical forensic lab could wear many different hats. So they could be responsible for that initial presumptive testing of the evidence. So looking for, say, blood, semen, or saliva on the item. They could be responsible for the DNA analysis of the evidentiary sample collected from that particular garment or item that was submitted to the lab. They could also be the interpreting analyst, so actually generating and or reviewing the DNA profile to make sense of what was collected from the evidentiary item. And then they can also be in a supervisory role where they're overseeing a team and then reviewing several cases simultaneously, looking at the interpretation results to make sure that everything was done correctly. So it really will depend on where you work, but in one lab, you may wear all of those hats, and in another lab, you may only wear one hat. But inevitably, the goal of being a forensic biologist or being a forensic geneticist in the lab is to process the evidence as best as possible in order to get to some type of conclusion that will hopefully assist the case one way or another, with no vested interest, but only objectivity in best representing that evidence to hopefully close the case.
Interesting, thanks.
Okay, so regarding your journey to becoming a forensic scientist, how did you know you wanted to pursue a career in forensics?
So I actually really wanted to be an accountant for a long time. And sometimes I still miss math, but when I read a paper in 11th grade about how Alec Jeffreys used magical DNA fingerprinting to apprehend a suspect that would have otherwise went unknown, I was really fascinated at the power of science and its application to justice. And so it was in that moment, 11th grade biology, that I decided that I wanted to pursue a career, or at least a future, in science, and see how I could essentially give back or help a potential person, potential community, etc. So volunteerism and community service are very, very important to me. They are components of my life in both my personal and professional lives. And I feel that forensic science is a field that allows me to consistently contribute to my local and larger communities. And it's in that passion that I continue to push forward in the field. But ultimately, I really love science. I really love biology, and I find DNA absolutely fascinating. And so it was just that sheer interest in the material that I was learning, my general desire to keep learning every day, and then that desire to be able to utilize my brain or utilize my talents to then give back to my community, to potentially solve a case, to potentially make a difference in the way we process evidence, whatever it may be, that keeps me moving in a forward and upward direction as a forensic scientist today.
That's nice. So going between 11th grade biology and where you are now, what kind of path did you take and how did you get here?
So obviously before 11th grade biology, my aspirations were a little bit different. So at that 11th grade turning point, I reached out to my counselor at the high school to be like, do we have any forensics programs in Canada? What do they look like? And UTM's program was just the most reputable by far at that time. And I think still has a pretty strong reputation, which is really wonderful. And so I decided to apply to UTM's forensic biology program. And I applied to a couple of other places for various scientific degrees. But when I was accepted to UTM's program, I just knew that that was where I needed to go to really explore that opportunity. When I completed my undergraduate studies at UTM, I did a double major in forensic science and biology because I didn't quite know exactly what direction I was going to go in. So I tried to keep my academic commitments quite broad so that I had a little bit of a foundation in everything. Once I left UTM, again, not quite sure what I was going to do with my undergraduate degree, I then went on to move out west, and I ended up working with the RCMP in more of an administrative role. And it was in that administrative role that I was like, okay, I'm kind of getting that feel for the police. I get really excited when they get called out to exciting potential crime scenes or this or that. And I realized that in that position, in that capacity, I wasn't really making the most of what I learned at UTM. So I decided to go back for my master's degree. And I did that in Albany, New York. And I completed a Master of Forensic Molecular Biology. And within that graduate degree, there was an internship component. And because I was in the United States, I didn't really know what to do for my internship. So I really cast a wide net and applied anywhere that offered any kind of internship. And so I was very fortunate that I had multiple offers, but I decided to go to the Minnesota Bureau of Criminal Apprehension in St. Paul, Minnesota. And in that lab, they were so welcoming. They afforded me an opportunity to do both a presumptive test research project and then a DNA analysis research project. So I really got a full understanding of what it's like to work on mock evidence, to work on, forensic evidence. And it really just continued to ignite that fire for me to keep going. And also in working there, I met a lot of very senior forensic scientists who are well known in the community. And that sheer exposure just was very, very fundamental to my desire to want to keep going. So I worked really hard to finish up that master's degree, and then I started applying for a variety of jobs, but I was also starting to look at a doctoral program. Once I finished at the University of Albany, so I graduated early, I shaved off a full semester and finished the master's program in a year and a half. I, again, cast a very, very wide net, like a large net, for any available positions in the field of forensic genetics that didn't require US or foreign citizenship. So I was really applying all over with no really reservations about where I might go next, because ultimately at that point in my life, I was really just chasing the dream, accumulating some student debt, missing family functions, but really chasing that dream. And so I landed a really wonderful opportunity in New York City, where I went and worked for a year at the Office of the Chief Medical Examiner and met the most amazing group of colleagues and had the most incredible experience as a junior analyst in the field. But again, that desire to keep learning and pushing the envelope didn't go away. So then that took me to Texas, to the Center for Human Identification at the University of North Texas Health Science Center, where I completed my doctoral degree, which was very prolific. And that's where I really, really developed some advanced technical skills in the field. And then by some, I don't know if it was a twist of fate or whatnot, there was a position open back at UTM, and I came full circle right back to UTM as soon as I was finished my doctoral degree. So it's been a journey. I've moved around a lot, but I've been afforded some really fantastic opportunities. I've worked really hard for those same opportunities, and I've really just enjoyed the ride. So now here we are.
Now, as you have just explained, you've had many experiences, many different locations, many different people. But what was your most interesting experience that you've had throughout your career?
So that's a really hard question to answer, because I feel like something new is always happening, and like new things are always happening. I feel like I've had several defining moments in my journey as a forensic scientist. The experience that I had in New York City was incomparable. I have to say, for a young forensic scientist, fresh out of school, the diversity of case files that I was exposed to, the diversity of training opportunities, working with very progressive equipment, being in New York City as a small town girl from Canada, the whole thing was just so surreal. And there were just so many opportunities to learn and grow as a young professional. Also, I mean, living in New York City was super cool and something that not a lot of people get to say that they've done in their lifetime. So of course, that was definitely a very rewarding experience. But fast forward to, say, the last 1 to 2 years, as I'm now out on my own, building my own lab team, building my own independent reputation, I had the opportunity to give a lecture to the Innocence Project, which is an organization that utilizes DNA technologies to essentially release incarcerated individuals who have been wrongfully accused. And in that presentation, or in that lecture opportunity, the audience included attorneys like Barry Scheck, who's one of the most infamous attorneys of our time. And in that moment, I just had such gratitude for being offered that experience. And that experience came through my colleague from the OCME in New York City. So I think about how everything in my life has kind of led up to these big moments. And I'm hopeful that the big moments continue, but I'm still incredibly grateful for all of the moments that have already occurred. So I can't pinpoint anything specific, but in using the OCME as one example, things just continue to progress in a really wonderful way.
So switching gears just a little bit, what are some common misconceptions in your field?
So I think that that's a tricky question to answer because it really depends on what we're talking about. So, I mean, if you think about the CSI effect as one example, we have this understanding of what DNA evidence can do, but obviously for those students or those individuals who have a background or knowledge in forensic biology, we realize that DNA is only useful within a particular lens or within an appropriate context, and that it is not the be all end all in an investigation when it is the only thing there, right? We utilize DNA evidence to corroborate the rest of the story, and the DNA evidence inherently has to be relevant to whatever it is that is being investigated. And I think, like, when you think about TV shows, that's one of the biggest discrepancies between what actually happens in the lab to what actually happens in real life. And, you know, that quick turnaround time in 30 minutes, or all of those things that are really exacerbated in TV, don't actually play out in the lab. Like, oftentimes evidence will go into a forensic lab and could sit on the shelf for 20 days, 2 months, maybe 6 months, maybe longer, depending on backlogs, amount of staff or analysts available, you know, a variety of things, how the lab has prioritized their casework, just so many things. And so again, that builds into that CSI effect of what's actually feasible and what's accomplished in a forensic lab versus what we are led to believe. But then other things I think include just the power of DNA in general, right? There's a lot of fear around DNA collection, that if somebody takes your DNA sample, they're going to have all of this knowledge about you. But from a forensic lens, we're really targeting a set of core markers that don't really say a whole lot about you outside of the context of comparing it to another DNA profile. But now, as we move into these new technologies, especially with things like genetic genealogy and phenotyping and ancestry prediction, we're starting to blur those lines. And so those misconceptions aren't so misconstrued after all. Like that fear, I think, has a place now to sneak in to maybe make us a little bit more diligent about how we utilize DNA within a forensic lens. But I'd say those are the major things. I'm sure as students, you might be able to think of other things that you thought that I've then, you know, burst the bubble about. But
interesting, yeah. And like kind of going back to, you know, like students in Murata University, and there's going to be mostly students watching this podcast or listening to it. Do you have any advice for students who want to go into forensic biology, or I guess more specifically forensic genetics in the future?
So if you're already a student and you're already taking classes, one thing that I always encourage is really exploiting opportunities to further develop your technical skills. So Ness, as an example, you were in my 481 and you had to do a ton of extractions. But with every extraction, your technical skills get a little bit better and a little bit better. And the stronger you are at the bench, the more equipped you are to be thrown into a position where you're going to be doing a lot of bench work. But I also think that being a well-rounded student or a well-rounded individual who just is very passionate and wants to continue to learn and grow is very important, because this field is ever evolving. As soon as we get one thing online, something new has come out. And so we're constantly having to pivot and change and grow. And that can be really challenging because, you know, we like to master our craft, or we like to master our skill set. And so having that flexibility to be open to growing and learning consistently, I think, is important. One thing I always tell students who ask me what they should do with their lives or what their next step should be is to really decide what your priorities are. And that's a personal choice for each individual, depending on what they want their journey to look like. So I talked about my journey, and my journey was extremely hectic, but very prolific in a 10-year period. Like, I moved around a lot, I did a lot, I saw a lot, I met a lot of people, but I spent a lot of money, so I incurred a lot of debt. I missed a lot of events, I missed family functions. I never traveled for pleasure. I only traveled like to go back home, you know, for the holidays or important events that I needed to be at. Because financially it wasn't feasible. Some of these intro salaries are quite stringent. When I worked in New York City, it was not a very lavish salary, but I will say I am so rich in experience from that opportunity. So it's really, really just a matter of deciding what you want your life to look like, where you want your forensic career to go. Because if you're a UTM student and you're like, I really just want to work at the CFS, or I really just want to work for like a local law enforcement agency, you're going to be waiting for those very few opportunities to surface. And then you're going to be competing against a large pool. Sorry about that. I thought I closed all my windows. And so for me, that's not what I did, right? I literally leapt and took off to all of these opportunities in very, very diverse locations, because that's where the opportunities were. But I understand that that's not the journey for everyone. And so again, just putting that back on you as an individual, thinking about what you want your journey to look like, but then remembering that you have profs like me who are going to write you that wonderful endorsement letter or recommendation letter to help you achieve those goals, should you want to pursue those big jumps or those big leaps. Or should you want to pursue the local opportunities if a job comes up for a technologist or a biologist at the CFS, or, you know, the Ministry of Health, or whatever it may look like in our local area. Just thinking about what do you want out of your science degree? What do you want to do that's going to keep you happy at work? Because if the pandemic has shown us nothing else, it's that life is so precious and life is so short that we really just need to be making the most of every day, of all of our experiences. And I just truly believe in choosing a profession that you are enjoying on a daily basis. So long-winded, but those are my words of wisdom as students progress on your journey.
Yeah, that's quite helpful. Thank you, especially as someone who's currently trying to take those next steps. It's a good thing to think about. Thanks.
I agree. So focusing now a little bit more on your current research, right now a lot of it is based on DNA mixtures and their interpretations. So what are some of the major challenges with DNA mixture analysis, and how is this type of analysis relevant to a forensic case?
Okay, so DNA mixtures are by far one of the most, and remain to be the most challenging aspects of forensic DNA typing, forensic DNA analysis, pretty much the field of forensic genetics. Because if we don't know how many people are in a DNA mixture, and we don't know how much DNA they contributed to the mixture, we rely upon very, very convoluted statistical modeling, which is in the courtrooms. It's very, very helpful, but we are reliant upon these algorithms or these models to really give us our confidence in the evidence. And I think that while that is very helpful, it's hard to explain to the jury sometimes. Sometimes the analysts don't fully understand the math behind it. And we're really just stuck in relying upon the stats when I think we could go back and improve upon the biology to then not have to so heavily rely upon the stats. And what I mean by that is that when you generate a DNA profile, you are given an output or a DNA profile electropherogram that displays all of the information for your given genetic targets that encompasses everybody whose DNA was in the sample on the screen. If we pick additional targets that are in the genome of every living, dead, whatever individual, if we find different genetic targets in the human genome that allow us to distinguish between individuals a bit better, then our biology inherently improves, meaning that we can, as interpreting analysts, review the data and better understand who might be in the mixture. And then we're further applying a statistic to increase our confidence rather than so heavily relying on that statistic to develop the models to explain the evidence. And so while that's still quite a complicated explanation, the end goal is to just look at additional information from the human genome that will allow for better differentiation of whoever is in the mixture. And we do this because we inherently know that most of our DNA is shared between individuals, right? 99.7%. But we're looking at that 0.3%. And quite frankly, we're looking at much less than the 0.3%. We're looking at only a few areas of that 0.3% to tell people apart, because there's enough variability in those small sections of DNA throughout the genome that are unique for each person. And in that uniqueness, we can exploit it to then better understand what's happening in our DNA mixtures, to know that, Ness contributed these particular sets of information at this genetic marker, Michaela, this particular set of information, and Tasneem, this particular set of information, because your human genomes are each different at that location. And so we can tell you each apart in the DNA mixture. And we're not there yet, but there are labs like my own who are exploring what types of markers might work well and how these markers might be useful in better parsing out people in a DNA mixture. One day we'll get there. One day I'm hopeful that mixtures will not be the cumbersome challenge that they currently are. But with every day, our technologies are improving, our chemistries are improving, and the goals of the field are shifting in one way or another. And it's just always trying to stay in line with what the goals of the forensic community are, so that whatever research we're doing, we're making a contribution. We're just not wasting everybody's time. So that's kind of where that's at. But I am very, very passionate about the deconvolution of DNA mixtures, because there's nothing worse than a case being inconclusive or not resolved due to the fact that we can't make sense of the evidence.
Yeah, that's really interesting. Thank you so much for that. So unfortunately, that's all the time we have for today. So thank you so much, Dr. Novroski, for your time. Do you have any final remarks you want to make before we close?
Nope. You know where to find me. You can reach me at the UTM campus, or you can check out NicoleNovroski.com if you want to learn more about the lab.
Thank you so much. So that concludes this episode of Humans in Forensics. So if you'd like to hear more, please check out our other episodes of the podcast, and feel free to check out the IVNVI website or follow us on Facebook, Instagram, and even Discord. So thank you so much for everyone for listening.